Hello class 10. Today we will discuss the nuclear change in alpha, beta and gamma emission. When the nucleus have less number of neutrons and protons, then we will call them as stable nucleus because the nuclear energy is sufficient enough to bind the neutrons and protons inside the nucleus. But if the elements with large number of neutrons and large number of protons, in this case the nuclear energy will not be sufficient to bind the neutrons and protons together. Thus this kind of elements will have unstable nucleus. So in order to be stable, this nucleus will give out the excess amount of protons, and also sometimes it will give out the excess amount of neutrons. This process, in order to be stable, this process of giving out the excess protons and excess neutrons is known as radioactive decay. So radioactive decay, there are three types of radioactive decay, namely alpha emission, beta emission and gamma emission. So let's first discuss about alpha emission. As already learned that alpha particles are the particles containing the neutrons and protons. The neutrons, it has two neutrons and it has two protons, which is equivalent to the nucleus of helium, which has the mass number equal to 4 and the atomic number equal to 2. So alpha particles have two neutrons and two protons. So the heavier elements with a large number of neutrons and protons, when it decays and gives out the alpha particles, then the smaller or the new element which is formed, the new nucleus which is formed, will have less number of neutrons and protons within the nucleus. So this nucleus is called as the parent nucleus because from this parent nucleus a new nucleus is obtained after alpha particles are given out. This new nucleus will be called as the daughter nucleus, and these are the alpha particles. So in order to understand this decay process, we will take the help of the equation where X is the element with the mass number A and atomic number Z, which gives out the alpha particles with the mass number 4 and the atomic number 2, that is 2 neutrons and 2 protons, and thus the daughter nucleus which is obtained after the decay, let's say Y, has the mass number A minus 4 and the atomic number Z minus 2. We can simply understand that when 4 of the particles from the nucleus is out from this element X, then we can write down the mass number as A minus 4. So the mass number becomes A minus 4, and the 2 of the protons which are out from the nucleus is the atomic number, so Z minus 2 will give us the new atomic number of the new element or the daughter nucleus. So thus the resulting daughter nucleus has 2 protons and 2 neutrons less than the original parent nucleus. This means that the new element has properties similar to those of the element that is 2 places before in the periodic table. So let's say, for example, that the parent nucleus is uranium and the daughter nucleus will have the properties similar to thorium, or we can say the new nucleus obtained will be of thorium. The other example can be like if radium is the parent nucleus, then the daughter nucleus will be of radon. So let's look at the example. The parent nucleus X, after alpha particles are emitted, the daughter nucleus Y is obtained, which has the mass number 4 less than the parent nucleus and the atomic number 2 less than the parent nucleus X. So the example is again radium after emitting alpha particles gives out radon, and uranium after emitting alpha particles forms thorium. Okay, you can see the change. 226 minus 4 is 222 and 88 minus 2 is 86. Similarly, 238 minus 4 gives 234 and 92 minus 2 is 90. So this will be the example for the alpha emission. Next, beta emission. The elements with more number of neutrons than the number of protons will have the neutrons to disintegrate, forming proton and an electron. Now this electron will have very high energy and it will be the fast moving electrons. These fast moving high energy electrons are called as beta particle. So a neutron will disintegrate into a proton and an electron, and this electron will have the negative charge. So over here, let's say that X is an element with mass number A and atomic number Z. When it disintegrates to form the beta particle, then the daughter nucleus will have the mass number same A, but its atomic number will increase from Z to Z plus 1 and a beta particle will be formed. Have a look at this example. A carbon nucleus, after the beta particle is formed, a proton is added into the nucleus and thus the nucleus changes from the carbon 14 to nitrogen 14. The mass number remains same, but since the one of the proton is added, thus the atom changes from carbon to nitrogen, but the mass number of both the nucleus remains same, 14 14. Here a neutron has been converted into a proton with the emission of beta particle. This means that in periodic table there will be an increase if the beta particle is emitted by any element, then there will be the increase, or we can say the daughter element, daughter nucleus will be one place higher than the parent nucleus. So over here carbon is the parent nucleus and the daughter nucleus will be the nitrogen, so it will be one place higher in the periodic table. So the chemical equation that we can write is carbon with the mass number 14 and atomic number 6, after giving out beta particle, it will have the daughter nucleus will be of nitrogen with the mass number 14, that is same, but the atomic number is increased from 6 to 7. So there will be an increase in the atomic number. Next is gamma emission. If a parent nucleus or a daughter nucleus is in the excited state, or let's say it is at high energy level, then that energy is given out or emitted by the nucleus in the form of electromagnetic radiation. So this electromagnetic radiation is called the gamma radiation. In this gamma radiation, there will be no change in the nucleus. That means there is no change in the mass number and the atomic number. So if there is any element which gives out gamma as electromagnetic radiation, then there will be no change in the atomic number and there will be no change in the mass number. Both mass number and atomic number remain same. Let's say an element A with the mass number X and atomic number Y, after giving out the gamma particles, not the gamma particles, it should be gamma radiation, then it forms the same element with the same mass number and the same atomic number. So over here, only to make the equation to understand clearly, it is written A and B. But A and B having the same mass number and same atomic number will remain same. Only the difference is A is in the excited state or at higher energy level and B is at the stable condition, that is at low energy level. So here we have the element with the excited state. This star indicates it is at the excited state at higher energy level. After emitting gamma radiation, the element comes to the ground state. It becomes stable, and if it is further at higher energy level, then it will again give out the gamma radiation. But this is at the ground state. It is not excited anymore. So this radiation keeps on continuously. It keeps on emitting until the daughter nucleus comes to the ground state. The electron emitted in beta decay does not exist in the nucleus. It is created by decay of one neutron into proton inside the nucleus and is instantaneously emitted. The electron does not stay inside the nucleus. In a single radioactive decay, alpha and beta particles are never emitted simultaneously. There will be either alpha emission or a beta emission, which may be followed by gamma emission. The daughter nucleus formed after the emission may again be radioactive and it may further decay by emitting alpha or beta particles. This continues till a stable nucleus is obtained.